Yes. Hello friends. Welcome to the Ken Academy. My name is Surendra. In this video, I'm starting one important topic in power systems is Perunit system analysis. We know that the understanding of Perunit system analysis concept is very important to solve the different models of questions in power systems. Not only in power systems, even in electrical machines also, if you want to solve some models of problems, Perunit representation is very important. With respect to Perunit system analysis concept, in the sequence of videos, I want to discuss following concepts. First, I will start with some introduction, then necessity of Perunit system. This necessity of Perunit system is theory concept, mainly important for ESE point of view. Who are preparing for engineering service exams to answer any theory questions with respect to Perunit system, to answer any descriptive questions with respect to Perunit system, the necessity of Perunit system theory concept is important. And after that, I will explain what is the exact definition of Perunit value, then how to represent various electrical parameters in per unit, both in single phase and three phase. One more important concept is how to convert per unit values from one base to another base. In this, one important formula I will give, that is very important to solve the different models of questions. Then after discussing this concept, I will explain what is the per unit impedance of transformer. In this concept, I will prove that the per unit impedance of transformer at primary side is equal to per unit impedance of transformer at secondary side. That proof I want to explain. Then after completing this theory concept, I will explain some numerical examples. It includes GATE, ESE and PSUs questions and some extra questions also I will explain. Then the last concept with respect to per unit system analysis is how to draw the per unit impedance or reactance diagram for a given single line diagram of power system network. Now how to solve the problems. Okay, these are the concepts I want to discuss with respect to per unit system analysis. Clear? See, my motive, I am giving the so many videos. I am going to give so many videos in my channel is, once I started one topic, one concept, in that concept, what are the possibility of theory, what is the possibility of formulas, all that in detail I will explain. With that knowledge, how to solve, if any numericals are there in that concept, how to solve those numericals. If there is any GATE or ESE questions or PSUs questions also are there, those questions with solutions in detail I want to explain. That is, students who are preparing for GATE or ESE, once you see my videos, then no need to refer any textbooks also. because I am giving possibilities, whatever the possibilities there in a particular concept, whatever the concepts I am giving, that concept no need to refer any textbooks also. Maximum possibility with theory, formulae plus different models that I want to cover. That is my motive starting this channel. Clear? Now, first we will start with some introduction. We know that any electrical system is represented in two ways. One is using actual quantities and using per unit quantities. That means electrical system is represented by absolute system and per unit system. This actual system is also called absolute system. That point you remember. It's also called absolute system, or this actual quantity is also called working quantity. It is also called working quantity. Then one more system is per unit system. This per unit quantity does not have any units, but actual quantity is having its own units. What is the meaning of this? For example, the actual quantity in the sense a voltage of 10 kilovolts, a current of 100 amperes, an impedance of 50 ohms, like this we can. That means every parameter is having its own units in the case of which system? Absolute system. But come to the per unit system representation, a voltage of 5 per unit, a current of 1 per unit, an impedance of 0.5 per unit, like this we can represent. That means in the case of per unit system, whatever may be the parameter, we don't have any units, just we are representing as a per unit. Okay, this is the main difference between actual system representation and per unit system representation. Students, you remember one point here. Actual quantities are having the units, its own units, but per unit quantities does not have any units. The reason later on I will give in the definition. In this point mainly you concentrate. Now, before going to the what is the definition of, what is the formula for per unit quantity or per unit value, first I want to explain what is the necessity of per unit system. See, one of the main advantage or necessity of per unit system is, let us consider one power system network. We know that a power system network consists of large number of components, like it consists of one generator, it consists of transformers, it consists of transmission lines, it also consists of some load or motor, like that. So many equipments or so many elements it consists. Then if you want to analyze this network, it takes more time. For example, take this network. If you want to analyze this network, it can be analyzed as a 3 sections. Once we are analyzing as a 3 sections, it takes more calculations and it takes more time also. That is the problem in the absolute system representation. But if you convert this network into per unit network, how to convert as a per unit network, all this later I will explain. If you convert this network into per unit network, then it is become as a single network. Once it become as a single network, then analysis becomes very simple. It takes less calculations, it takes less time. This is one of the main necessity of Perunit system with respect to power system. Clear? Next, one more necessity is, we know that many manufacturers for a different equipments, the impedance values are specified in terms of per unit. The rating of impedance is specified in terms of per unit, because if you represent in per unit, if any data is not available, the assumption is very easy in the case of per unit. This is the reason. This is the one more necessity of the per unit system. I think you already seen in the doing of some problems in electrical machines. Take the example of synchronous machine. Once the any quantities are given in per unit, for example voltage per unit is given, power per unit is also given, but current per unit is not given, then you take rated current is 1 per unit. That is our assumption. That means if the values are specified in terms of per unit, the assumption is very easy. Next, one more necessity you concentrate. If any system is represented in per unit, thus for a particular system values becomes, the range becomes very narrow. When the values are becomes very narrow range, if any erroneous data is present, in the sense incorrect data is present, that incorrect data can easily identified. This is one more necessity. Next, this important point, with respect to transformer, if the impedance is specified in terms of per unit, then the impedance referred to primary, the impedance referred to secondary is same. If both the impedances are same, primary impedance and secondary impedance is same, then replace the total transformer by one network only. That means separately, no need to analyze at primary and secondary side. You can join those two directly. Okay, that is the one more advantage representing in per unit. Next, this is also important point. We know that in a three-phase transformer, so many connections are there. Star-star connection without ground, star-star with grounding, delta star, star delta, star zigzag star, delta zigzag star. Like that, so many connections are there. Point to remember, the per unit value of impedance is independent of the type of connection, even though base values are depends on the type of connection. That means once we can represent as a per unit, the impedance values are independent of the type of connection. But in a normal, that means in a absolute system representation, in actual system representation, based on the type of connection, the impedance will change. But in per unit system representation, based on the type of connection, the per unit impedance will not be changed. All these are the necessity of the per unit system. Clear? Understand. This is one of the theory concept. Who are preparing for engineering service exams, we may expect the descriptive question like this. What is the necessity of per unit system? Write down all these points. That is enough. We may expect question like this also. What is the differences between absolute system and per unit system? Like that also we can expect. Then in that case, whatever the points I given here, all these points you write down at per unit system side. Exactly opposite, you write down the points at absolute system side. That is over. Like that we can answer any question based on this topic. Clear? Then go for what is the definition of the per unit value. Students, this is one important formula. All of you concentrate. The main definition of the per unit value is actual value by base value or reference value. The per unit value is defined as is a ratio of actual value to the base value, but the units of base value is same that of the units of the actual value. That is very important point. That means when the units of the base value and actual value is same, because of the same units, that 2 will be cancelled, that same units is cancelled, then no units. Per unit value does not have any unit. This is the reason why the per unit value does not have any units, because it is the ratio of the parameters having the same units. That is the reason why it does not have any units. Now the question is, I told already this actual value is also called working quantity. This base quantity or reference quantity is a arbitrarily selected value. That point to remember. Yes. Now the question is, sir, is it per unit value is always equal to 1? Is it always less than 1 or is it always greater than 1? That is our doubt. But point to remember, it is not always equal 1, it is not always less than 1, it is not always greater than 1. It may be equal to 1 or less than 1 or greater than 1, decided by the base value. Important point. The per unit value is mainly decided by the base value only. It may be equal or less than 1 or greater than 1, depends on the base value or reference value. Okay, clear? Now see. Then what are the different actual quantities are present? What are the different actual quantities are present? The actual quantities are voltage. These are the different actual quantity: voltage, current, resistance, reactance, impedance, active power, reactive power. These are the some of the examples of actual quantities. Then what are the base quantities? In general, in a power system, only two parameters mainly selected as a base values. Using that two parameters only, remaining base values are derived. Then what are those two parameters? Base voltage, apparent power. Apparent power and base voltage and apparent power is selected as a base values. By using that, we can derive any base value. Take the one example. I know the what is the apparent power base. I know the what is the voltage base, but I want current base. We know that what is the apparent power? Apparent power is nothing but we know this apparent power equal to voltage into current. Then base power. Then base voltage into base current. Then what is the base current? Apparent power base by voltage base. Then we can easily derive the current base. Once you know the current base, then how to derive the base impedance, voltage, base voltage by base current, like this. That means in power system mainly these two parameters are selected as a base. Using that, we can derive any other base parameters. That point you remember. Now the question is, sir, can you take reactance is the base? Can you take resistance is the base directly? No. We don't have any reactance base. We don't have any resistance base values. We don't have any reactive power base values. We don't have any power base values. This important point. We never take active power is the base. We never take reactance is the base. You never take resistance is the base. We never take reactive power is the base. This is very important. Sir, if active power and reactive powers are not taken as a base values, during the calculation of per unit active power, per unit reactive power, then how to take the base? Then which parameter we select as a base? That is our question. Yes, absolutely no doubt at all. If any active power, per unit active power you are calculating, per unit reactive power you are calculating, always you take the base is the upper end power only. Don't take active power and reactive power base. This one point you remember. Now the question is, sir, once I am calculating per unit reactance, during calculation of per unit resistance, then which is selected as a base? We never take reactance base, we never take resistance base. Always you take impedance base. Base is the impedance, not the resistance, not the reactance. Even though you are calculating per unit reactance and per unit resistance. A very, very important point, students. These points mainly concentrate during the defining or during the calculation of various, during the representation of various electrical parameters in per unit. These points are important. Now go for how to represent various electrical parameters in per unit. Students, this is very important formulas during solving of the problems. Okay, the first one is